Hello, everyone. I'll give a couple of more minutes for people to join in, and then we'll start.
Hello.
Yes, hello. I'm waiting for a few more minutes so that few more folks may join.
Okay, Laksh.
All right, I think we can start. So, welcome everyone, and welcome to this CCNA demo session. And I hope everyone had a great Diwali. So, happy Diwali to everyone once again. And I welcome every one of you to my CCNA demo session. So in today's session, this is just an introductory session, and this demo session will be in English. Okay, this demo session will only be in English. The other sessions, the actual sessions, when we really start the CCNA courses or sessions, they will be in individual languages, that is English, Hindi, or Tamil. So this demo session is only in English for now. And let me share my screen and also start our session here as well. So let me introduce myself first. My name is Laksh, and I work in Cisco systems, right? And I have almost 10 years of experience, and I have completed my CCNA back in 2015, CCNP in 2018, and CCNP Encore and NRC, both in 2022, if I'm not wrong. Yeah, CCNP Encore and NRC in 2022. And then I completed my CCIE service provider exam in the year of 2023. So along with that, I have another certification from a company called as Sienna. I'm not sure if you guys have heard of this company before. Sienna, I completed its Ethernet Associate exam. And if you want to connect with me, you can connect with me on LinkedIn by searching my name as Lakshmikant PS. That's my official name, Lakshmikant PS. You can connect with me on LinkedIn. And if you would like to watch my videos, it's on YouTube as well by the name of Network Bytes with Laksh. So the name is Network Bytes with Laksh. This is my YouTube channel's name. So if you would like to know more about the topics, for example, OSPF, I uploaded OSPF videos. I've recently uploaded BGP videos as well. So you can check out those videos as well on the channel. But for this demonstration, we're not going to discuss all that. We're only going to discuss what's here given in the agenda. So we'll discuss about computer networks, and then we will discuss what is CCNA, what are the CCNA syllabus that we will be working on in this course, and what can you expect from this course, and how would the labs in this course would look like. So moving on, can everyone hear me well? First, that's the first question that I would like to ask. Can everyone hear me well? Give a thumbs up. All right. So I see few people raising that. Yeah, you can hear me. All right. So, okay. So in today's demo session, I'm not going to dive into what is CCNA, what are the things. Okay, that's not what my training style is. I'm going to give you what is CCNA, I mean, what is network, and how CCNA will help you understand what is networks. So let's just understand networks first through a real-time example. Okay, so on the screen, you can see that there are two people. Imagine that this is your friend, or imagine this as yourself, and this is your friend. Okay, and both of you are chatting with each other over Facebook, right? So all you know is that you are typing some message on your phone on the Facebook, and your friend is typing some message on his phone or on his laptop or whatever device he is using, right? And he's typing the message. You can see his message, he can see your message, right? And all you know is that you are connected to your Wi-Fi. So your phone is connected to the Wi-Fi network in your home, and his laptop or his phone is connected to the Wi-Fi modem in his home, right? So that's all you can see, right? And for most of the people, this is what internet is. You are connected to the Wi-Fi. You are connected to the internet. Okay, so that is what people think is internet. But let me tell you, that's not what internet is. Okay, what goes in between these two Wi-Fi routers is what internet is. Okay, and today is what we are going to discuss. And this is just one of the example that I have shown you. Like, we use Facebook, we use internet to use Facebook, we use internet to chat on WhatsApp, we use internet to browse on Google, we use internet for banking transactions, and we use internet for our daily entertainment, that is Netflix, Hotstar, or Prime, or any other OTT services, right? So internet, we are surrounded by internet. In our hand, it's a phone that is connected to internet. In front of you, it's a laptop, it's connected to the internet. Nowadays, we have smart TVs which are connected to the internet. We have smart refrigerators there, they are connected to the internet. So everyone, everywhere is connected to the internet, right? And can someone tell me what is your understanding of internet? What do you mean by internet? Can someone tell me what do you understand by internet? Anyone? There's no need to be shy. There's no right answer. There's no wrong answer. Everything is subjective. Internet itself is a subjective thing, right? So there's no need for you to be shy or embarrassed about answer.
Data transfer between the connected devices.
All right. So someone said data transfer between devices. All right. Anyone else would like to give it a shot of what is internet? Okay. Someone mentioned on the chat medium to communicate. All right. Medium for communication. Right. Anyone else? All right. So data transfer between devices and medium to communicate. Okay. Again, as I said, there's no right answer, there's no wrong answer, right? But let's first expand the word internet. Internet is just a short form. Okay. Internet actually means interconnection of networks. Interconnection of networks. So when I write NW, that means networks in short form. N/W means networks. All right. Now, interconnection of networks. Okay. We understand what is interconnection, right? It means connection between different things is what interconnection means. Now, what is network here? What is network? Okay, let's just understand that part. So, as I said, there's a Wi-Fi router in your home, and you are connected through a mobile phone to the Wi-Fi router. Okay, you have a TV which is connected to this Wi-Fi router. You have a laptop which is connected to this Wi-Fi router. And not just this, your family members, whoever are using the smartphones, they are connected to this Wi-Fi network. And not Wi-Fi network, meaning Wi-Fi modem. So this Wi-Fi modem is continuously sending Wi-Fi signals, right? So what is happening? You, along with your family members, have using this Wi-Fi modem, have created your own network, a small network in which all your mobile phones, all the smartphones, all the smart TVs, all the laptops, all of them are connected. Okay, and not just this, you are talking to your friend, okay, who is sitting on his couch, right, and browsing Facebook and talking to you, right? He is also connected to Wi-Fi at his home, right? So even he has family members who are using mobile phones. Even he or she would have a smart TV or a laptop that is connected, right, to this Wi-Fi modem at his home. So what is happening? The Wi-Fi modem at your friend's place has formed a small network of its own, right? Now all these devices are talking to each other, right? It's a perfect example. You are sitting at your home beside your father or your mother, and you're sending reels, you're sending forward messages over WhatsApp. You can talk to someone inside your network, as well as you can send messages to someone who is not in the part of your network. So what is happening here? This is what you call it as inter-network communication, right? So this is one network, this is one network, and there's a communication between two different networks. That's what you call it as inter-network, right? That is what internet means. Connectivity between two different networks is what internet is. Many people think Google is internet, Facebook is internet, Netflix is internet. No, that's not internet. Internet is connectivity between two networks. Google is itself a network. Facebook itself is a network. Meta or your X, Twitter is itself a network. How do you connect to them? That is the study of internet. That is what we are going to learn. Okay. Any question before I move ahead? Any question? Anyone?
No question.
Yeah, no question? Okay. Now, so before we jump into trying to understand how things work in the world of internet, okay, let's try to understand something that you can see in front of you, which is called as OSI or TCP IP model. Whoever is new to the world of network, do not worry. Do not worry. I'll explain all this thing in today's session. Okay. Now let's take the example. Okay, let's take the example of roads. Okay, we have roads in a city, and imagine this as a crossroad or a junction, right? So these are roads, and there are vehicles that are standing at the signal, right, on all the four sides. And what would happen? There would be a traffic signal, right? Using the traffic signal, the vehicles are moving. The vehicles are moving around, right? If anyone wants to take a right turn, until and unless this traffic signal gives a right turn signal, the vehicles can't go. If the signal is for go straight, the vehicles will go straight. If the signal is to go left, the vehicles would go left. If the signal is stop, the vehicles would stop. So what is happening? The vehicles are following, or we, like, we are driving the vehicles, we are following the rules. And because of the rules, the traffic is moving smoothly. What if this traffic signal goes down? Like, there is no traffic signal. No, there is no light on the traffic signal. So what would happen? All of them would try to go everywhere, right? And what would happen? There is going to be a traffic jam or congestion. So similarly, in the world of internet, you need some rules and regulation so that whatever messages or whatever data you send or whatever data you're receiving should be able to work smoothly. And who makes these rules and regulations? Those rules and regulations are made by these two models, the OSI model and the TCP IP model. The OSI stands for Open Standard Interconnect, and TCP IP model stands for Transport Control Protocol or Internet Protocol model. Using these two rule book, the data in the internet is flowing between each and every devices. Okay. Any question here? Anyone? Okay. So now, yeah, is someone saying anything?
Nothing. Don't
Okay.
have any questions.
No problem. Thank you. So here, do not be scared looking at this diagram. You do not be scared looking at this diagram. It's okay. I'll explain you each and everything in today's session. Okay. And so here, what you see is, you can see there are 7 layers. Okay, starting from the bottom layer, that is layer number 1, up till layer number 7. These are what you call it as OSI layer models that we saw just now. As I said, the rule book, Open Standard Interconnect. Okay, this Open Standard Interconnect has 7 layers. Okay, 7 layers. And you may wonder, where are these layers residing? These layers are residing in your networking devices. When I say networking devices, I mean that whatever device that you use to connect to internet, or whichever device can connect to the internet, is a networking device. And all of those devices have these layers inside them. Okay, you do not have to go searching of where are they. They are all present inside your networking devices. Okay. So we'll go one by one through each of these different layers today in this demo session. Okay. I am going to use all the real-time example as to where do you see these layers in your real life experiences, so that you will try to understand, or you will be able to connect with the internet. Okay. So the first layer will go from bottom to the top layer. Okay. So the first layer you see here is a physical layer. Okay. And before I go on, you can see the first or the top layer here is the application layer. Now, all of us, I'm using a screen. I'm using my laptop. You guys must be using your phones or laptops to connect to this session, right? So whatever you are seeing, whatever you can hear, whatever you can watch, okay, that is happening at the application layer of your device. So WhatsApp, Facebook, whatever you do, everything is happening at the application layer. So what happens is that when you're using Facebook or WhatsApp and you send a hi message to someone, right? You are sending the hi message, which is at the application layer. And what happens? That hi message gets encapsulated. I'll talk about encapsulation in just a while, but just keep this in mind. Encapsulated, the word encapsulated, which means that the application layer, whatever message, this hi is a kind of a data for your machine, for your laptop, for your phone, or for your even for your smart TV. You're watching Netflix on your smart TV. That is an application. But for the TV, it's a data, right? Whatever data, right? Whatever data you see on your application layer gets encapsulated. When I say encapsulated, I'm pretty sure you guys would have been sick and you would have swallowed a capsule, right? You would have swallowed a capsule, right? Now, if you have ever opened the capsule, right? Capsule is just the cover. When you open the cover or when you break the capsule, you can see small medicine balls inside it. That's the actual medicine that you're supposed to swallow, right? But you cannot swallow it directly. That is why it is covered with a plastic, which is edible. You can digest, your stomach can digest it. Similarly, whatever data you write or whatever data you see in the application layer gets encapsulated inside a lower layer. Okay, we'll talk about these layer in just a while. Okay? Do not worry. It gets encapsulated in the lower layer, then lower layer, then lower layer, then lower layer, then lower layer, and finally it reaches the physical layer. Now, as I said, all these layers are inside your networking devices, inside your phone, inside your laptop, inside your smart TV, everything. So the only two layers that you can actually physically touch, the two layers that you can actually physically touch is the application layer and the physical layer. When I say physical layer, all your motherboards on your laptop, the USB port, the cables, the right, they are all at the physical layer. When you open your laptop, the motherboard, the fan, etc., they are at the physical level. Application layer, you can touch the screen that you see on your phone, the screen that you whatever application that you're working on. I'm running Zoom right now. Okay, it is being live streamed at the YouTube. I can watch the YouTube as well. So what is happening? I can interact with the application layer as well. So these two layers are the only layers of a networking device where you can touch or feel. The rest of the layers you cannot. Why? Because everything is going inside your physical layer, meaning your motherboard. Okay, uh, like an electric pulse. Those electric pulses you cannot feel, touch, or see. Okay. Now what happens? Whatever messages that you sent at the application layer, that finally comes down to the physical layer. Now, example, I'm using a laptop, you're using a phone. So what happens? Your phone's Wi-Fi adapter, your phone's Wi-Fi adapter would convert. We know that our machines, they understand only binary numbers. Binary number mean 101010. They understand only this. So what happens at the physical level? Your Wi-Fi adapter of your laptop or your phone converts this binary number into a Wi-Fi signal. A Wi-Fi signal. If you're connected through a cable, it will convert into a light pulse or an electrical pulse, right? And it will send it out. It will send it out. Now what happens? It will go through the internet that we always see. It will go through the internet and it will reach your friend's Wi-Fi modem, or your friend's Wi-Fi modem will send it as a Wi-Fi signal to your friend's phone. Your friend's phone's physical layer will convert that signal into binary form once again and will send it back to the top layer of his phone, that is the screen, and that is how he can view your hi end on the FB page. This is how things actually work in your internet. And as I said, everything is happening inside your networking device. You do not have to go anywhere out. Okay. Before I move on, any question here? I know this may be a bit complicated to understand for now, but trust me, by the end of this session, you'll understand why did I explain this first. Any question here? Okay, great. Now, as I said, we'll start with the bottom layer, the physical layer. Okay. So in the physical layer, you will always see, as I said, you can touch and feel the devices or the things at the physical layer. And whenever we talk about physical layer, it's mostly the wires. You can see there are so many wires. You have RJ45, you have an RJ45, okay, you have an optical fiber cable, you have an HDMI cable, this is a USB-C cable. All the wires and cablings that you see, okay, that your networking device is connected to, that is at the physical layer. Okay, even your USB port on your laptop, that is at the physical layer. Okay, so as network engineers, myself being network engineers, I rarely deal with physical layer. Because, okay, we network engineers always deal above the physical layer. When we work as network engineers in our real-time jobs, we never deal with cables. That dealing of cables is usually done by our respective field engineers. Anyone here is a field engineer? Anyone here is a field engineer? Okay, no problem. So field engineers, okay, mostly work with cables. They work with hardware devices. They work with your networking devices. They help you to plug in the cable, pull out the cable, or remove the cable, make changes in the location of the devices, etc. Okay, and I really appreciate the work they do. Without them, probably we will not be connected. Because of them, we can connect different devices through cables. Okay, it's because of them. It's because of these field engineers that we work. Okay, so as I said, in networking, as network engineers, we will rarely deal with physical layers until and unless you start as a field engineer. Okay, and as I said, field engineer is not at all a bad role. It's a great experience to understand how the device looks like, how the cabling works. That is also important. Okay, and where would we always see these cables? The first time that I remember, the first time that I came in contact with this physical layer was in my computer lab. I'm pretty sure you would have seen some kind of connectivity like this in your computer lab. So you can see there's a LAN cable, there's a telephone cable, and there is a cable TV cable, etc. So this is where your physical layer comes. So there is nothing to worry. As I said, physical layer and the application layer are the only two layers which you can touch. The rest of the things you cannot. Okay. So I encountered the physical layers at my computer lab. Can anyone else tell me where have you seen these cables in your daily life, in your home, in your office, or at some other place, etc.? Where would you have encountered these cables?
No, in the home we are having it, right? That's how it is connected to the Wi-Fi.
Correct. Yeah. Even our Wi-Fi modem. Correct. So the Wi-Fi modem, right? Wi-Fi modem is connected to a cable, right? So the Wi-Fi modem box itself is a physical layer. The wire with which your Wi-Fi modem is connected is also a part of the physical layer. Okay. And if you would have let's say I have a local connectivity, but if you would have, whenever you ask the internet service provider to give you a connectivity, two people will come. If you would have noticed, two people would come. Okay, they would install the Wi-Fi. Okay, and they will have a small machine. Okay, with which they will splice the cable or cut the cable and insert it into the Wi-Fi modem. So those two workers are not workers. I should not call them workers. They are field engineers. Okay, and trust me, if you are starting your career as a field engineer job, do not worry. It's a great learning experience. Once you have a great learning experience as a field engineer, trust me, once you move ahead in your career, you will have a greater visualization of a device rather than people who have never worked with physical devices at all. They're just network engineers. Okay. So this is the physical layer. Any question with physical layer? No? All right. So moving on, the second layer is a data link layer. Do not worry. There are so many different layers. Do you need to remember it? No, you do not need to remember it, because as we study more and more, these layers, name of the layers, what is going on in the layer will it will be stuck in your brain forever. So don't worry about that. Now coming to the second layer, data link. Let me tell you a story of this is my understanding and this is my story. Okay, so what I understand is that when the computers were invented, when the computers were invented, they were invented with the purpose of doing faster mathematical calculation, faster maths. That is what computers were invented. I'm not sure if you have seen this movie, The Imitation Game. It's from Benedict Cumberbatch is there. He acts as a Turing, Alan Turing, right? He created the machine Enigma, which was used to create complex mathematical calculations to work out an algorithm and end a war. Okay, so computers, as I said, computers were created to do mathematical calculations faster. And as the technology developed, more and more computers were created. More and more computers were created. Okay. Now, when more and more computers were created, we wanted these computers to talk to each other. So what did we do? We connected them through wires. We connected each and every computer through wires. Okay. Now, what happened is that there was a problem here. The problem is, as more and more computers were created, all the devices need to be connected to each other. That was a problem. So if I have 100 computers, that means one computer should be connected to 99 other computers. That means I need 99 ports or 99 interfaces on my computer. Okay, imagine your laptop having 99 interfaces. How many interfaces do your laptop has? Just probably 3 or 4. Okay, nowadays even that is probably you'll see only one USB port. Okay, nowadays in Apple laptops there are no USB ports at all, right? So imagine in that time if I had to create 99 ports on a computer, that is hilarious. Okay, that is crazy. So I cannot do that. Okay, it will take me forever to manufacture such computers. So what I did, I created a device, and that device was called as a hub. I created a device, that device was called as a hub. And this hub will be connected to all the computers. Okay, all the computers. Now, imagine there are 4 computers, computer number 1, 2, 3, and 4. So what happens is that when the work of hub was very static. Static meaning if PC number 1 or computer number 1 sends a data, what the hub will do is hub will copy this information and send it to all the computers connected to it. So what would happen? PC number 1 need not be connected to each and every device. All it needs to be is to be connected to the hub, and the hub will do the rest of the work. Hub will copy that data and send it to everyone. That is what it used to do. Okay, and hub was the first unintelligent device. First unintelligent networking device. Why unintelligent? I'll explain you in a bit. Now, obviously, as networks started to grow, I wanted that only PC number 1 can communicate to PC number 2, meaning only these two can communicate. Whatever data PC number 1 sends, it should be received by PC number 2. Whatever data PC number 2 sends, it should be received by PC number 1. 3 and 4 should not receive that data. But with the hub, that was a problem. The problem was if PC number 1 sends a data, obviously the hub is going to send it to everyone. That was the work of a hub. That is why I called it as an unintelligent device. An unintelligent device. So in order to solve this problem where I want one-to-one communication only, okay, I created another device. And I called it a switch. In short, I'm writing it as SW, switch. Okay. Now, with switch, what I can do is I can ask PC number 1 to send a data, and it will go to PC number 2 only. Or I want PC number 1 to send data to PC number 3 only. It is also possible. So how was it possible? So we came up with few features called as MAC addresses. We'll talk about MAC addresses in further sessions. Okay, MAC address. MAC address is just like our home address. Okay, MAC address is just like our home address, where PC number 1 will have a MAC address. PC number 2 will have its own MAC address. All that PC number 1 needs to do is write its own MAC address, that is PC number 1's MAC address and PC number 2's MAC address, and send this data towards this switch. The switch will read the MAC address and forward the data to PC number 2. So here what happened? Switch was an intelligent device. How was it an intelligent device? Because it could understand the MAC addresses. And based on the MAC address, it forwards the data to a particular device. Right. Okay. Any question here? Any question here about, I just gave you a brief of what is a hub, what is a switch. Okay, I did not go into the detail, but any question here?
No, only question is like when you are sending packets from 1 to 2, how will the 1 knows about the MAC address of 2?
Yeah. See, for a demo session, like, this is enough. If I go deep into it, it will go beyond that. So as I said, do not worry about what is a MAC address, how a switch work, how a PC works, how PC knows about other MAC addresses. We will discuss that post the demo sessions. Okay. For now, to introduce demo session, all I just wanted to show you is what is computer networks and where do we encounter these devices in real. Okay. So you see here the MAC address. How many of you, I was born in 1992. Okay, how many of you are from that period? Okay, before 2000. How many of you were born before 2000? Okay, so give a thumbs up. Okay, that's okay. Now, people who were born before 2000, or even like probably 2008 or 10 something. Okay, I would say 2005. Right. We used to share songs. Okay, our favorite songs. Okay, that time we had mobile phones, but they were all keypad mobile phones. Okay, but those keypad mobile phones had Bluetooth. Okay, had Bluetooth. Even now, nowadays, my laptop, even the headphone that I'm wearing, okay, is running on Bluetooth. Okay, it's connected to my laptop to Bluetooth. Okay. Anyway, going back there, we used to share songs with other friends over Bluetooth connectivity. Okay. If you remember, I just used a word called as MAC address. Bluetooth uses MAC addresses to transfer your data wirelessly. Okay, wirelessly between two mobile phones. Even my headphone is connected to my laptop wirelessly over Bluetooth using only the MAC address. So my headset also has a MAC address. My headset has a MAC address. My laptop has a MAC address. Those two MAC addresses are matching over Bluetooth connectivity. Right. So, as I said, internet, you're surrounded by internet, and I just introduced you with MAC address and how you are connected to it right now. So, even your, these things. Even now, smartphones have Bluetooth connectivity. Not smartphones, sorry. Smart TVs have smart remote. Those smart remotes are connected using Bluetooth. How? MAC addresses. How are they connected? We'll talk about that in detail later. Okay. And now, coming back to our discussion on the switch. So as I said, switch was the first intelligent device. Now, using switch, have you ever wondered, like, for example, this is your campus. This whole picture is your campus. Okay, this is building number A, building number B, this is building number C, this is building number D. Okay, so have you ever wondered, imagine this as your college campus, and it's a huge campus. Okay, it's a huge campus. How is your building, the computers in your building, connected to the building or connected to the computers in building number D? Obviously, the wires are not that long. Okay, probably a few meters. Okay, imagine your campus being huge, probably of 3 acres, like an IIT. It's huge. IIT campuses are huge. Okay, so have you ever wondered how your computer in building number A is connected to any other computer in any other building? That is again through a switch. That is again through a switch. How? As I said, switch can be connected to different PCs. Okay, and the advantage of a switch is that it can be connected to different other switches as well. This is switch number 1. This is switch number 2. Okay, and on this there will be multiple other PCs connected. Multiple other PCs are also connected at this. So you can expand your network. Okay, you can expand your network by connecting different switches together and connecting different PCs on it. So that is how that is what you see here. All these buildings or all these PCs are connected through a switch. And in real time, when you start working on as a network engineer, you will have a chance to get inside a server room. You will have a chance to get inside a server room. And I just showed you what is at the physical layer. You see, these wires are at the physical layer, and they are connected to each and every switches. And each of these wires are connected to different switches. And this whole picture is a part of a server room. And that is how you are connected to a lot of other devices. Where do these wires go? They go underground. Okay, they go underground, and you would have seen, imagine your hometown, and a new road is built. And after a month, there will be these guys from telecom company, and they will be digging, path on the newly built road and putting wires. That is, like these wires are going through those big wires where the municipality people are digging a path in your newly built road. That is how things work. Anyway, so these wires help you connect to different switches and also to help you connect to different networks. Any question with layer 2? I'm not going in depth about what is layer 2. Okay, but any question with layer 2? Okay, moving on to the next layer, that is layer 3. So, all right, before I missed one more thing. Now, by connecting different switches together, or even just one switch, okay, one switch or multiple switches together like this, what happens is you are creating something called as a LAN. Okay, LAN full form is local area network. Okay, local means it's a small, its own satisfactory area. It is sufficient in itself, right? So this itself is a LAN, or this is a LAN. Okay, this is a LAN, or this whole college campus. You see here, this whole college campus in itself is a LAN, right? This itself is a LAN. So LAN can be of just 2 devices, 3 devices, or probably 100,000 devices as well. It depends on your requirement. Okay. So anyway, why did I talk about LAN here is, I'm not going to talk further about LAN, but the reason I spoke about LAN is I'm going to introduce something new in your third layer, that is network. So you see here, this is a LAN, meaning this is a LAN of itself, where you can see multiple devices are connected to a switch. This is a LAN itself, where you can see this is a Wi-Fi modem, where you can see a printer, a laptop, and a tablet is connected. This is again a LAN network. You can see where there are multiple devices connected to a switch, right? And if you want 2 different LAN networks, right? You are in your home, and your home network, it's in itself is a small LAN network. You are able to talk. I am sitting in my home talking to you guys, okay, delivering this session. My home Wi-Fi modem has created a small LAN network, which is able to communicate to your LAN network, to every other LAN network in this world. How is that possible? That is possible through a device called as a router. So you see here, what is a router doing? A router is basically connecting different LAN networks together. So the Wi-Fi modem at your home, okay, which is connected through a wire, is basically connecting to a router, okay, which then is connected to your friend's Wi-Fi router. This is the internet. Okay. Inside the internet, your Wi-Fi modem is connected to a router, and through the internet, it's connected to your friend's Wi-Fi modem, and then it is sending the Wi-Fi signals. So to connect different LAN networks, you need a device called as a router. Okay. And to better understand the layer 3, let's take the example of the map of India. This is a partial map of the South India. Okay. So how do you visualize layer 3 in your device or in networking? How do you visualize? Okay. Imagine that there are two cities. One is Coimbatore, the other is Chennai. Okay. I want to go from Coimbatore. That means Coimbatore will be my source and Chennai will be my destination. I want to go from Coimbatore to Chennai. At this stage, I'm completely ignoring the train journey. I'm completely ignoring the air journey or journey through flight. I'm just taking roads as of now. I'm just taking the example of roads here. So what happens is that for me to start from Coimbatore and reach the city of Chennai, I have multiple ways. Okay, I can go via this path or the shortest path like this. Okay, or I can just go around leisurely, going to Mysore, going to Bangalore, Vellore, and reach Chennai. I have different ways. Okay, so in the world of networking, these roads, okay, these roads are called as IP or Internet Protocol. Okay, now this Internet protocol, as I said, can be visualized as roads. So roads are already built there. The roads, as I said, are already built by whom? By the government. Similarly, IP is already built between the networking devices through the wires, through the protocols. You do not have to do anything. Roads are already built there. You don't have to do anything. Okay. Now, on roads, we have vehicles. We have different vehicles like buses, cars, motorcycles, sometimes pedestrians, etc. So in networking, these vehicles are called as routing protocols. We'll talk about routing protocols in later part of our CCNA sessions. But for now, just understand that these vehicles are called as routing protocols. Okay. Now, these, as I said, we have different vehicles. We have different we have different vehicle types. We have bus, we have cars. Okay, we have two-wheelers as well. Right? Similarly, we have different routing protocols. Okay, and how are we based on our requirement? Okay, based on our requirement, we'll use either the bus, we'll use the car, or we'll use a two-wheeler. And all these vehicles have their own pros and cons. Bus has a higher capacity, higher seating capacity, but it is very slow. Cars is fast. Cars is fast, but it has less seating capacity. Similarly, two-wheeler is fast, but it has its own pros and cons. Okay, you can comfortably go using a two-wheeler. Okay, however, it is slower than car, faster than bus. Only two people can ride. Okay, and you have to go through a lot of heat, rain, dust, etc. So similarly, in networking, these routing protocols also have their own pros and cons. Based on these pros and cons, or based on your requirement, you will use these routing protocols to go from Coimbatore to Chennai, or to go from one place to the other place. How do you do that? Which cars, which vehicle should you choose based on your requirement? Everything will be discussed at a later point. Now, the lanes of the road. Obviously, we have 2-lane road, 4-lane roads, 8-lane roads, and the newly built highways are having 10-lane roads. Okay. So what is happening here? With the lanes, the width of your road is increasing. And as the width of the road increases, you will be able to go faster, right? So at a 2-lane road with heavy traffic, probably you will be riding at a speed of 20 kilometers. Right? And 4-lane road, your speed may increase up till, for example, 50. 8-lane road, you may go up till 100. Right? 10-lane road, you may go up till 120 kilometers per hour speed. Right? So what is happening? As the width, this is the width, and this is the speed. As the width of your road increases, your speed also increases. Why? Because the traffic gets divided and you can go between the vehicles and reach faster. Similarly, in networking, this is called as your bandwidth. This is called as your bandwidth in networking. You would have heard in your when you are buying an internet connectivity, in your home, and they would say the download speed or the upload speed is 60 Mbps, 100 Mbps, 20 Mbps, etc. What is that? That is bandwidth. The more your bandwidth, or the more your downloading speed, the faster your internet connectivity is. Right? So a person who's using a 20 Mbps speed internet, okay, and a person who has a 50 Mbps internet speed, this person will have a slower internet, and this person will have a faster internet. Why? As I said, width of your road. Similarly, bandwidth of your network or your connectivity. This is called as bandwidth in network. Okay. So lanes in real life is equal to bandwidth in networking. Now, where does router come in all this? Okay, I just introduced to a new device called as router here. Where does router come in all this? Okay. So you can see here from Coimbatore to Chennai. Okay, let me take the middle road. Okay, so there are different cities that I go through: Erode, Salem, Tiruvannamalai, Mahabalipuram, Kanchipuram, etc. Right. So these cities or these stops, okay, or the different locations that I go through is the router. Okay, so what happens? Let's imagine on your Google map, you type source as Coimbatore and destination as Chennai. The Google map shows you the path. Basically, it's not red in color, but it's blue in color. Let me change the color here. So it gives you a blue path like this, right? Now, if you if you tap unmute and let the goddess Google talk, okay, let the Google lady talk, what happens? Okay, so she would say, to reach Chennai, take this NH, turn right, turn left, etc. right? She gives you all that instruction, but then she keeps saying, keep driving on this road. Okay, in some time you will reach E road, right? Once you reach E road, she'll say, take a left, take a right, or stay on the same path to reach Salem. Okay, once you reach Salem, she will say, take a left or take a right, whatever. Okay, to go towards Tiruvannamalai. The same thing happens till you reach Chennai. Similarly, in internet, these routers do the same thing. These routers are like locations. So what happens whenever a data comes to a router, the router checks to which next city or next router should it send so that it reaches the destination. I am currently sitting in the city of Pune, okay, and wherever you guys are sitting, okay. For example, let's say someone is sitting at Delhi. So what happens? My data is going to the first router. That first router is checking to reach Delhi, what should be the next router. The next router is checking to reach Delhi router, what should be the next router. Like that, finally, my data is reaching to your laptop or to your mobile phone, whichever. Okay. So any question here, understanding the layer 3 part here? Question? No. All right. Move on. Probably the next one should be an interesting one, where you would have seen these messages popping up on your WhatsApp. You can see here, I have a couple of WhatsApp screenshots. Okay, so here you can see a sent received, read receipt message, and then you can see a not delivered message, download failed message, and this message waiting for this message, this may take a while, etc. Obviously, all of us have encountered these on our phone, WhatsApp. Okay, so you sent a message, right? You sent a message to your friend. The message is sent. The message from your phone is sent. How does your phone know? Okay. How does your phone give you a single tick mark? Okay. When that message is received by your friend, okay, it gives you a double tick mark. How does your phone know? When your friend reads that message, it gives you a blue tick mark. How does your phone knows about it? Everything is happening at your friend's side, but how does your phone know about it? That is the work of transport layer at your phone and at your friend's phone. Similarly, you sent a message. Okay, cool. What do you think? It does not get delivered. How does your phone know? It did not deliver. Okay, how does your phone know that this message was not delivered there at your friend's phone? Okay, why is this message not working? How does your phone know that this message did not reach your friend's phone? Right? Or waiting for this message. How does your phone know that it is waiting for some message? Right? How does your phone know? It is all because of the transport layer at your phone and the transport layer that is in your friend's phone. So the transport layer, okay, the transport layer helps in giving us these information. And what are these informations? Basically, these informations are basically acknowledgement, right? These are basically acknowledgement. Your friend's phone is giving an acknowledgement that it is sent. Your friend's phone is sending a message that it is received. Your friend's phone is sending a message that your friend has read the message. Your friend's phone is saying that it's not delivered. Your friend's phone is sending an acknowledgement that it is waiting. That is why your phone knows about it. So with the transport layer in your phone, it is able to send acknowledgement towards the other device. So two phones, until and unless they have an acknowledgement factor, they have an acknowledgement between them, both the devices will not know that the message is received or not. For example, I'm talking to you, okay, and when I ask, can you guys hear me? Is there any question? When you reply or when you acknowledge, then only I would come to know if you have a question or not. When I ask you, can you hear me? Can you see me? Can you see my screen? Until and unless you give me an acknowledgement saying, yes, we can see your screen, or no, we cannot see your screen, or yes, we can hear you, or no, we cannot hear you, then only I will come to know that what is happening on the other side. That in your device is the work of transport. The acknowledgement that the device is, the data is successfully sent to the other side is the work of transport. So in transport layer, this successful or unsuccessful reception of messages is done by two protocols. One is called as a TCP protocol. The other is called as a UDP protocol. I'm not going deeper into them. Okay. Another example of where do you see TCP or UDP is that whatever UDP means, that UDP full form is user datagram protocol. We'll discuss about this later. User datagram protocol. Okay. How now whatever message or whatever you can see on your screen or whatever I can hear, everything is happening at user datagram protocol. Okay, meaning that whatever live is happening, whatever live matches you watch, live cricket, live basketball, live football, or even this Zoom session, or whatever live streaming that I'm doing on YouTube, everything is happening at UDP. In UDP, there is no acknowledgement. No acknowledgement. Meaning that if I am talking to you and because of some problem in the internet, slow internet, or some other problem, what will happen? My voice will break. You may not see my video clearly. You may not see my screen clearly. Okay. And that is not going to repeat. That will never be repeated. It will be a continuous stream. Just like a live match at Hotstar, live cricket match you're watching. Okay. Imagine, okay, Shoaib Akhtar bowling. Okay. Shoaib Akhtar bowling. And suddenly, Sachin is batting. Imagine Sachin is batting. Okay. And Shoaib Akhtar bowls. Okay. The moment he bowls, your screen freezes for 5 seconds. Screen freezes for 5 seconds. Right. And after 5 seconds, you see Sachin is out. You don't know what happened at that 5 seconds. You cannot even, nowadays at Hotstar, you cannot even repeat that 5 seconds or 10 seconds. It's live. That is what UDP is. Imagine what if an acknowledgement is received. Okay, show a bold, your screen froze for 5 seconds, and again it started to continue. Sachin is going to the pavilion. Suddenly, you see that Sachin is getting bold after that. So you see what is going on. You just showed Sachin is going back to the pavilion. Now you're showing Sachin getting out. What is this? That is because your TV sent out an acknowledgement. In UDP, there is no acknowledgement, and all the live streaming that you see happens over UDP. Let me give you a live example right now. Let me capture the data that is being sent from my Wi-Fi modem to all of you guys. Okay, so if you see here, yeah. So if you see here, it says UDP, User Datagram Protocol. Why? Whatever messages or whatever data that is being sent from my laptop to all your devices is happening live, and it is happening at UDP level. So where do you see TCP or this one, TCP? Wherever you need an acknowledgement, like banking transactions, especially in banking transactions, when you give your customer ID into the bank's site, right? What happens? Your bank's website fetches all the information and shows you the display. If your bank is not able to, if your bank is not able to send you the information, what happens? There will be an error, right? Error, something went wrong, like that. Right? Then your Netflix, whatever you watch at Netflix, right? What happens? Your PC is sending continuous data to the Netflix server. The Netflix server is continuously sending back the data to your PC. If your server is unable to send the data, or because of some reason the data did not go well, what happens? It starts to buffer, right? Buffering means the server is sending data, your PC is collecting all the data. When all the data is collected, it will your PC will start streaming your movie once again. How does that happen? It's because of PC. And in Netflix, you can rewind the movie, you can forward the movie. How? Because both the devices are sending each other acknowledgement. So all your live shows, whatever you do, everything happens at UDP. Wherever you need acknowledgement, wherever you can control the flow of data, that happens at transport. And with transport layer, you get reliability. You get reliability, correct? You can rewind a movie at Netflix. You can forward the movie at Netflix. Guys, sorry. My internet just went down.
No problem, Lex.
So again, yeah. So this is a problem of network. So because my internet went down, you guys were unable to see me, right? Or view my screen or anything that was happening. So why? You were unable to see my screen. Again, my data was not being sent to you. But that is why everything stopped. Okay. And moreover, you did not receive any kind of communication that something went wrong on my side. Why? Because everything was happening over UDP, right? So a great example here. And I think, I thank my internet connectivity that went down, because of which I was able to give you a real-time example again, once again. Now, the last layer, the layer 5 here, the application layer. Okay. So have you ever wondered, if you type google.com on your browser, what happens? You will see something, some circling going on, and suddenly your page being loaded, right? What
Like,
happens?
you are not sharing.
Your PC. Oh, okay. Sorry, I'm not sharing my screen. I'm sorry. Yeah. Thank you. Now can you guys see my screen?
Yes.
All right, thanks. So when you type google.com, what basically happens is that obviously your computer does not understand what google.com is. As I said, it can understand only ones and zeros, right? Google.com it cannot understand at all. What happens? It needs to convert this google.com into a binary thing, right? It needs to convert this thing into a binary number, right? Or it needs to convert this into something else called as an IP address. Okay. MAC addresses and IP addresses are just like our addresses, as I mentioned, IP address and MAC address. So what happens is that google.com is converted into its respective IP address that your PC or your computer understands. Okay. Then what happens? With this IP address or the IP address of the google.com, your PC here, as I shown you here, TCP connectivity. The TCP connectivity here that you see, your PC will create a TCP connection with your Google server so that you can receive acknowledgement from the Google server. Your data is reliably transferred to the other side. Google's data is reliably transferred over to your side. That happens over a TCP connection. So your PC creates a TCP connection with the Google server. Once that is created, once a TCP connection is created, the Google server then starts to send different type of data over to your PC. Like if this is a Google server, you will see the Google logo here, right? And you will see some other information over here. You will see some information over here. You will see Gmail, login, etc. All those plugins. So all those plugins again is sent over that TCP connection. And finally, you will be able to see your screen being fully loaded. And how does that happen? That happens at your application. So if you see here, whatever is happening, you typed google.com at the application layer, okay, and your PC created a TCP connection. TCP connection that happens at layer 4. Okay, now whatever information is being sent between your PC and the Google server is happening over IP. That is happening at layer 3. Okay, using MAC addresses at layer 2. Okay, and how are they able to communicate? Your PC is receiving that data through Wi-Fi signals, or through a Wi-Fi adapter, or through an Ethernet cable, or through a cable. Right. Similarly, at the Google side also, it may have a cable. So what is happening? It is happening at layer 1. And that is why I introduced you first with something called as encapsulation and decapsulation. So here we discussed 5 layers, right? So as I said, there are 2 types of OSI. There are 2 types of rules and regulations. OSI has 7 layers, and TCP/IP has 5 layers. The only difference between TCP/IP and OSI is that This is OSI layer model. Okay. And in TCP/IP model, what happens? The application layer, the presentation layer, and session layer are clubbed together and called as application. That's the only difference between an OSI layer model and a TCP/IP model. The working remains the same. There is no difference there. So in OSI layer model, you have 7 layers. In TCP/IP model, you have 5 layers, where the 5th layer, 6th layer, and 7th layer are clubbed together and called as application. So you see how you are completely surrounded by internet in your daily life. Okay. Any question in these layers before I move on? No question? Okay. Now the main agenda for which you guys have joined, right? What's in it for me? So once you understand what is internet, and if you have a good understanding how internet basically works, okay, how internet basically works, you can work for different companies. Okay, network engineers are in demand currently, and I believe networking or any kind of job that involves, or any kind of telecom jobs. Okay, inside telecom you have networking also. Okay, so any kind of telecom job that you do is always safe. Is always safe. Okay. During COVID time, we were the we were always working. I was always working. Okay, because of network engineers like me, we were able to do work from home. We were able to communicate with people over Zoom. We were able to communicate with people over Teams, etc. Okay, all our work was still going on. Why? Because of telecom, because of network. And there are different types of networking companies. So there are 2 types of networking companies. One is a product company, the other is a service based. Now, what are the difference between these two? Product companies are those companies which actually make networking devices or networking products like Cisco, IBM, Nokia, Juniper. You can see all these companies that basically make their own networking products. And there are other companies like service companies that are called as in India. These are the service companies that you see: Infosys, TCS, Wipro, HCL, etc. They do not have the networking products. They give services. Okay, they give services to the product companies, saying that we have services. Who are those services? The employees. We have employees who can work for you. We are giving you services, or employees as service. Make use of them. Okay, so Infosys or any service-based companies will have contract with the product companies, and you can indirectly work with those companies as well. And which are the departments you can work? You can work in wireless, cyber security, ethical hacking, coding, automation, etc. You can work in all these departments. But first, before you jump into any of these, you should start from the basic. You should always start from the basic. Okay. So how do you start from the basic? That is CCNA, okay. Cisco Certified Network Associate. Then you jump into CCNP concentration. Then you jump into CCNP specialist, CCI, and the final is CCDE. But you always start with CCNA. Okay. And as I said, this course is all about CCNA. So we'll start from the basic, Cisco Certified Network Associate. Right. And if any one of you are wondering what are the other courses in Cisco's or different certifications, so these are the certifications. So you can see entry level, associate is CCNA. Then in professional or CCNP, you have these many certifications in different regions. or different technologies, right? Like wireless, service provider, enterprise, collaboration, security, data center, etc. Okay. Once you clear CCNP, you can write the expert exam. Any of the expert exams, CCI, you have different CCI, enterprise, infrastructure, service provider, collaboration, data center, etc. And the final or the top most level Cisco exam is CCD, that is design expert, Cisco certified design expert. Okay, so this is the toughest Cisco exam, right? So we will be going through CCNA in our course this time here, CCNA, right? And what we will be looking at in the CCNA? Let's check that. So we'll be looking at these topics in the CCNA. Okay, these are the new topics. We will be looking at routers, what are switches, right? Based on routers and switches, what are the things that we will be learning? We will be checking that. Okay, how is our network designed? We will be checking that also, right? We will be looking at different types of cablings, etc. You can see compare TCP and UDP, right? What are addresses? As I mentioned, IP addresses. What are IP addresses, right? We will be looking into all those things, and we will be checking switching side also, LAN. You can see here VLAN. We will also check VLAN as well, right? So we will be looking into the switching part, right? What happens with switching, etc. And then we will be looking into the routing side, as I mentioned, routing protocols. We will be checking routing protocols also. We will be checking with routing protocols. We will be checking other few features like DHCP. We'll talk about DHCP later. Okay, DHCP, SNMP, etc. Then we will be checking security. Your network needs security, so we will check security as well. Then a few automation and programmability as well. These are the things that we will be going through in the CCNA session here, right? And any question about the course? So yeah, a few more things about the course. The course duration is going to be 60 hours. Okay, for all the languages, English, Hindi, and Tamil. For all the languages, the course hour is going to be 60 hours and 5 hours a week. And based on the diversity of people who are joining, I may club two languages together, probably English Hindi or English Tamil, etc. And the lab is going to be from Cisco Packet Tracer and GNS3. Both of them are open source devices. I mean, Cisco Packet Tracer is not open source. You do not need to pay for Packet Tracer. Okay, you can easily download it. GNS3 is an open source. You can freely download it. You can freely download it from the internet. I will also show you how to download GNS3 as well as Cisco Packet Tracer. Why these two softwares? The reason is that you do not have to rely on physical labs. You can create your own lab on the software, which exactly works like the real world. Okay, so you do not have to book a rack. You do not have to book a device. You do not have to book some you do not need to worry about the connectivity. You do not need to worry about connectivity to the lab, connectivity to the rack, or someone else using the lab, etc. Everything will be for yourself. All you need to do is just download Cisco Packet Tracer and GNS3 on your system, and you can start working on your own. So that is why I always prefer Cisco Packet Tracer and GNS3, even when I'm training on CCI as well. It's the best thing. Okay. Any question regarding the course, regarding uh, anything else? Yeah. You guys are free to ask me any question.